In this video, we are going to see how to create threads on a bolt. So here you can see a bolt with the square threaded bolt with the square threads. So we'll see here how to create it. So on the tree you can see here the tools used to create this kind of thread here. So we have used shaft, pocket, and the slot command. So we'll learn how to create slot command as well as how to create threads using slot and the helix, the new command called helix. Okay, so just let me delete this all the commands and start from the beginning. Everyone are welcome to give the commands in the command box. All the feedbacks are welcome, whether it is negative or positive, so that I'll improve the video quality or video content. If some things are unnecessary or not required, so just you can let me know. So we'll start with the sketching again. Similar thing again. Select the plane and we'll draw the center lines here. We'll draw a center line here, and we are going to use shaft command to create a bolt. So what we need to do is we need to create the cross section. When we see the front view, we need to create only the cross section of the bolt. Just we'll use the rectangle, create two rectangles here. We'll create a rectangle here and create one more rectangle here and delete the unnecessary segment. To delete the unnecessary segment, we have the quick trim selected and remove the unnecessary segment and just close this section. Close this section. Now we need to define the dimensions. Take the constraint tool and define all the required dimensions. So once all the required dimensions are defined, select the multi constraint, edit multi constraint, and change the all dimensions value. So this here, so whichever is highlighted, that is the dimension that is selected, that will be highlighted here. So just we change the dimensions. So here in this my sketch which I am drawing here, it's given as 9 by 32. Just we no need to do the division multiplication, the calculations directly. Software will do it. So just you have to in whichever form the values are given, you just need to type the values. So here it is given as 1 by 4. So just type the values. So 1 by 4 and automatically software is going to calculate. This dimension is given here as it is given as 1, and this here is it is not given here. This one is again 1 and click OK. Okay, once all the dimensions are defined, or you can do one thing, just will delete this dimension and these two are two lines. So with the profile we can make this line as a 1. This line is 1. Come out of the command, and OK, define this dimension and delete this one. Okay, okay, we can't delete that. Okay, right. So what we can do is we can give this dimension. This dimension is not given. The dimension is not given here. So we delete this one and define this dimension. So this is given as 3 by 8. So 3 by 16. Sorry. So define it 3 by 16. Okay. So once you define all the dimensions, next thing is there is arc here. You can move the dimensions at your convenience, and there is arc here. So I'll draw a line here and just escape and define the dimension for this value, this line. You can just move the dimension as per your convenience, and here it is given as 1 by 16. You define the value and take a 3-point arc. So go to the circle command, select the 3-point arc with the limit. So this is the first point, this is the second point, and you draw the arc. Now select the center point and select the center line, the line here, and go to constraint and select the coincident. So there is no need to define the arc value here, the radius here. We need to delete this because this is the intersecting part, and because we have deleted that, we need to define one more dimension here. So just define the dimension and define the radius here. Okay. Next is just exit the workbench and revolve this geometry. So just select the shaft feature and click OK. So once you got the bolt, there is a section here. So we go to the sketching again, select the plane again, and we simply create a rectangle here. So take a centered rectangle from this rectangle tool, and from the center point create a rectangle here, small rectangle. Create the rectangle here and just define the dimensions. So there is a dimension here. This is given as 3 by 16. So just define the value here, 3 by 16, and increase the height. Okay, next dimension is we need to define this dimensions. Okay, so this is given as 3 by 32. We define the dimension and height. There is no requirement to define the height anyway. There is no material up here. Exit the workbench and remove the material. So just we go to the pocket and select the feature and select the mirror extend. So both sides it is going to remove the material. Once you created this feature with this slot here, now the main thing we need to create a thread. So to create the thread, either you can go to the start mechanical shape, and in shape you can go to the regenerative shape design, and you can select the helix feature here. You can select, you'll enter into the surfaces and you can select the helix. So where is the helix feature here? Select the helix feature here, or the better option is you need to change here anything, just be in the part design. Just now I changed, so just be in the part design, and in the command prompt here, this is the here command prompt here, just like AutoCAD we can type it here, the name of the command, C colon name of the command, helix is the command name, and the helix command will appear. So now the starting point of the helix we need to define. So the starting point will be on this curve. Just we create a starting point here, create a point here, create a point, create anywhere on this curve, and click OK. Now once we created a point here, we need to select axis here. So for this thing to be clear here, just click on this particular axis, different axis. So when you click on the axis, the plane will appear, right? So here this plane, ZY plane. So this is the ZY plane. Here you can see Y is here. So here this is going to be Y. So you can select a Y axis here. Just directly right click here and select a Y axis here. Okay, so you can see thread is going in right direction. So we know that this is our correct direction. Now height is going to be 0.85 and the pitch value is, for this case, 0.1. So once we define a whole thing, the threads are going to, the helix is going to be created. So once we have created the helix, now we need to create a section or the profile that is going to follow this helical path. So to create the profile at particular point or the particular area, we need to create a plane first. To create any kind of sketch, we need to create a plane first. So how to create a plane? Just we go to the datum plane here. So there is an option called datum plane in here. So you can see here. So these are the reference element. So just shift and click left click so that you can convert this commands into vertical orientation. So these basically are vertical orientation. You can convert into horizontal orientation. So these are the reference element: point, line, and the plane. So select the plane here, and we need plane normal to the curve. So just select the curve and select the point at which you want to create a plane here. So this plane at this point I want the plane that is to be normal to the curve, and click OK. So once we have created a plane here, we go to the sketching again and select the plane, this particular plane. Now depending on what type of thread, we create a section. So for my section I'm going to create a circle here, and circle will create a square thread. So select a point here and select a point on the this curve, and go to multi constraint dialog box. Actually it's not selected. Select a point here and select a point on the curve. Go to constraint dialog box and select the coincident. So once we have selected coincident, now we need to define the diameter of the circle. So this diameter is going to be 0.05. So this diameter should be less than the pitch value. Otherwise, whole thread, all the threads are going to collide with each other. So that is the restriction here. The dimension of the diameter of the circle or the other any other element should be less than the pitch value. So once you have created the circle, then exit the workbench, and the next thing is we are going to use the slot command. So there is a slot command here. The slot command will remove the material in the given direction and with a given profile. So this is the profile, and the center curve is this one. So this profile is going to follow the path of the center curve, and it is going to remove the material. So once we click OK, so now we have created the thread here. So now you can see how to create the threads. Any kind of thread you can create, whether it is trapezoidal, square thread, metric. The commands or the tools we have used, you can use see from the tree here: the slot, the helix, the pocket, and the shaft. Okay. Okay, thank you.